An important type of matrix we can talk about is what's called an elementary matrix, right? What this represents is a matrix that when we multiply it onto another matrix, it does one of our row operations for us, right? So the actual definition here of an elementary matrix, we would say an n by n matrix is an elementary matrix it's an elementary matrix if it can be obtained from the identity matrix via one row operation. So the identity matrix IN, but I don't know why I put a comma there, by a single row operation. Right. So, this says, like, if I take the identity matrix and I swap any two rows, for example, right, that would be an elementary matrix. Of course, the identity matrix itself is elementary. If we, say, take a row and we multiply it by a number, that would be an elementary matrix. Or if we take a multiple of one row and add or subtract it to another one. Right? So some examples here. Let's do, say, 3 by 3 examples. Right? So notice in particular, actually we'll do a couple different sizes. But remember, if to be an elementary matrix, it has to be a square matrix. So 2 by 2, 3 by 3, 4 by 4, and so on, right? So let's look at a few examples. This here would be an elementary matrix. All right? This is an elementary matrix. Why? Well, what we did is we took the identity matrix and we swapped the first and second rows. Okay. Another example. Maybe we do something like 1, 2, 0, 1. That's an elementary matrix. What did we do here? So actually, maybe we'll write underneath here. This one was R1 swapped with R2. What single row operation did we do here? Well, we did row 1 plus 2 row 2 goes to row 1. Right? We did a single row operation. All right. And let's see, what's the other one we haven't done yet? Ah, yes. Let's write down a 4 by 4 one. 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, minus 3, 0, 0, 0, 0, 1. Right? What did we do here? We took row 3 and we multiplied it by negative 3. Right? So these are sort of like the 3 ways we can build an elementary matrix. Okay? So how do we know kind of what their how these act on other matrices? Right? Like I said at the beginning here, these elementary matrices, what they're sort of intended to do is when we multiply it onto another matrix, it should do that operation. All right? So let's see how that works out. Right, so let's take an example and say, let's do some 3 by 3 stuff just so it looks a little interesting. Let's say we do 1, 0, minus 2, 1, 4, 2, and 0, 3, minus 1. That seems like a good enough matrix there. All right, and what we want to do, actually, let me even change this to a 5, just so we have a variety of numbers in here. All right. So what we want to do is perform a bunch of different operations on this. Right? So let's say our first goal is to swap row, 1 and 3. Right? And I want to do this with elementary matrices. Okay? So what we're going to do is copy our original matrix here. Let's copy this. This is A. Right? And we're going to write down the elementary matrix, which swaps rows 1 and 3. Well, to do that, we just take the identity matrix, the 3 by 3 identity, and swap rows 1 and 3. Oops, that was supposed to be a 1. Right? So here, if we swap these rows back, you see we had the identity, right? Okay? So, here's our elementary matrix. Here's our matrix A. And if we multiply this out, we should swap rows 1 and 3. So, let's see. So here, we got 0 times 1 plus 0 times 1 plus 0 times 1. Or, well, 1 times 0. So that gives us 0. Here we have 0 times 0 plus 0 times 4 plus 1 times 3. So that's going to be 3. And here we have 0 times negative 2 plus 0 times 5 plus 1 times minus 1. That's minus 1. All right, let's move to the next row. 0 times 1 plus 1 times 1 plus 0 times 0. Oops. That's 1. 0 times 0 plus 1 times 4 plus 0 times 3. Here's our 4. And minus 2 times 1. Oh, sorry, minus 2 times 0. 5 times 1, 0 times negative 1. And lastly, the bottom row, 1 times 1 plus 1 times 0 plus 0 times 0. 1 times 0 plus 0 times 4 plus 0 times 3. And, oops, 1 times minus 2 plus 0 times 5 plus 0 times negative 1. There you go. So, this has swapped row 1 and row 3 in our matrix A. It's kind of interesting how these work. So basically, if we want to represent with matrix multiplication how row operations work, we begin by saying, all right, what row operation do I want to do? Do that to the identity matrix, and then take that elementary matrix you just found and multiply it onto A. On the left. Specifically on the left side. This won't work on the right side. Right? If you're curious why, try it out. But we have to multiply on the left. Alright? Alright. What's another interesting operation we can do? Let's do the easy one here. Let's multiply row 2 by minus 1 over 7, because why not? Right. There'd be no good reason to want to do that, but let's do it anyway. Right. So, I'm going to just copy this whole thing here, because we're going to have something very similar. Right, so we need to come up with a new elementary matrix here. Right? So if we're multiplying row 2 by negative 1/7, we need to take the identity matrix and multiply row 2 of that by minus 1/7. So we're looking at something like this. Right, does that make sense? So we took row 2 in here, and we multiplied by minus 1/7. Right? So now when we multiply this out, right, I'll say this out. So we have 1 times 1 plus 1 times 0 plus 0 times 0. 1 times 0 plus 0 times 4 plus 0 times 3. 1 times minus 2 plus 0 times 5 plus 0 times minus 1. Right, here we have 0 times 1, negative 1/7 times 1 plus 0 times 0. Okay. 0 times 0 plus negative 1/7 times 4 plus 0 times 3. And negative 2 times 0 plus negative 1/7 times 5 plus 0 times minus 1. So that's minus 5 over 7. Right, and then the last row will be 0 times 1 plus 0 times 1 plus 1 times 0. 0 times 4 plus 0 times... 0 times 0 plus 0 times 4 plus 1 times 3. And negative 2 times... or 0 times negative 2 plus 0 times 5 plus 1 times minus 1. Alright, there we go. What we did there was we took this second row here of A and we multiplied it by minus 1 over 7. Alright, so hopefully you're kind of seeing how these elementary matrices work. Now again, I want to emphasize we need to multiply these on the left. Okay? So let's do one more example, which is the more interesting one here. Or maybe I shouldn't say more interesting, but more complicated row operation, which is the one where we combine rows, right? Am I calling these? Yeah. So here, let's say we want to do what's a good one? We can do row let's do row 1 minus 2 row 3. Right, so 2 times row 3. Let's do that. Right, so the row operation we're looking at is row 1 minus 2 row 3. And we're replacing row 1 with that specifically. Right? Like here, you know, this one is minus 1/7 row 2 goes to row 2. And this one here was row 1 swapped with row 3. Right? Alright, so let's go ahead and do this operation first on the identity matrix. Right? So we know the second, or the last 2 rows don't change. Here we're doing row 1 minus 2 row 3. So that would give us this. Alright. So let's actually move this over a little bit so we have a little more room. This computation will be slightly more interesting. Right? Alright, so let's do our usual computation here and see if this really does give us row 1 minus 2 copies of row 3. Okay, so here we have 1 times 1 plus 0 times 1 plus minus 2 times 0. Right? Here we have 1 times 0 plus 0 times 4 plus negative 2 times 3. That's minus 6. And 1 times minus 2 plus 0 times 5 plus negative 2 times negative 1. Let's go on to the next row. 0 times 1 plus 1 times 1 plus 0 times 0. 0 times 0 plus 1 times 4 plus 0 times 3. 0 times minus 2 plus 1 times 5 plus 0 times minus 1. 0 times 1 plus 0 times 1 plus 1 times 0. 0 times 0 plus 0 times 4 plus 1 times 3. And 0 times minus 2 plus 0 times 5 plus 1 times minus 1. Right? And if we simplify this, 1, 1, 0, minus 6, 4, and 3, 0, 5, minus 1. Alright? And, well, if we look out what we're supposed to get, if we do this row operation on A itself, like if we just kind of talk about it, right? So it would be 1 minus 2 times 0, so we get a 1. We have 0 minus 2 times 3, that would be minus 6, which is what we got. And here we have negative 2 minus 2 times minus 1, so that's minus 2 plus 2, which is 0. And ta-da, that's what we have. Right? So these elementary matrices here, they let us do row operations on an actual matrix A. Now, there's a very sort of important use of this, which is that all of these elementary matrices are invertible, right? Because they're all obtained from the identity matrix by one step, one row operation, right? All of these are invertible. And since they're all invertible, if we can sort of chain a bunch of them together to turn A into the identity matrix, then what we've sort of done is come up with A inverse if we combine all those elementary matrices together. All right? So hopefully that seems kind of interesting there. And we will talk in the next video a bit more about why that's useful.